Hey guys, I welcome everyone to my YouTube channel. This is Ashok. As we know, we are delving into the ever-growing demand of data science and the plethora of opportunities it presents. From business to healthcare, finance to entertainment, the demand for data-driven insights is skyrocketing, and the data scientists are at the forefront of this revolution. And today, we unveil the exciting roadmap of becoming a data science mastermind. So buckle up guys as we explore the wonders of AI, machine learning, deep learning and more. So let's go ahead and see what all topics we are going to cover in this data science roadmap. So I request everyone to watch the video till the end. Now at its core, AI is about creating systems that can learn, reason and act autonomously, much like the humans, but with the ability to process huge amount of data at incredible speeds. So one of the most common applications of AI is the predictive analytics. By analyzing the historical data and identifying the patterns, the AI algorithms can predict the future outcomes with remarkable accuracy. We'll understand what artificial intelligence is and how machine learning, deep learning, computer vision, natural language processing, and generative AI fits into this bigger umbrella of artificial intelligence or AI. So we'll understand what is data science life cycle, starting from your identifying problems and understanding the business to data collection to data processing, data analysis, data modeling, and the model deployment. Next in the list is Python. Python acts as our trusty companion throughout this journey, offering a plethora of libraries and tools tailored for data science. From NumPy and Pandas for data manipulation to scikit-learn and TensorFlow for machine learning and deep learning. Python provides a versatile ecosystem that empowers the data scientists to tackle complex problems with ease. So guys, these are the few of the topics which I've included for specifically Python. So we'll start with Python basics. We'll understand few of the data structures of Python like list, tuple, set, and dictionary. We'll understand what is lambda. We'll understand iterable, iterators, and generators. Then map, filter, and reduce functions. Exception handling in Python, which is very important. And then at the end, we'll see few of the Python libraries specifically for data science. So guys, next in the list is statistics. Now, statistics plays a very crucial or a pivotal role in data science. So typically this statistics means collecting, extracting, analyzing, summarizing and visualizing the data to extract some kind of conclusion, insights, trends, patterns or some kind of valuable information from the data set itself. So I have included a few of the topics which I'm going to cover in statistics, starting from descriptive and inferential statistics. We'll see continuous and discrete, mean, median, mode, basically the central tendency of the data set. We'll understand about the empirical formula. We'll see normal distribution and standard normal distribution. We'll also see what is this normalization and standardization, and we'll see what happens if you have a skewness in the data or what happens if you have outliers and how to handle them. And hypothesis testing is very much important in statistics. We'll understand that, and then at the end we'll see a few of the statistical techniques or statistical tests. So next in the list is machine learning. So in machine learning, computers learn from the data without being explicitly programmed. They analyze the patterns and relationships within the data to make predictions or decisions on the unseen or the new data. Next, we'll understand about machine learning life cycle, and then we'll understand about what is supervised, unsupervised, and reinforcement learning, and what is the basic difference between these three. Now, the supervised learning is again classified into two analysis. One is a classification and regression analysis. In classification, we'll understand about few of the algorithms or the models, starting from logistic regression to Naive. Next, these are the few examples of the classification algorithms. Next, we'll understand about the regression analysis, where we are going to see few of the algorithms starting from linear regression to ridge and lasso regressions. Now, this is the example of regression analysis, where we'll see regression line, error term, and also we'll see how you'll calculate this best fit line. So next we'll understand about the unsupervised approach. We'll see clustering algorithms in case of unsupervised, starting from k-means plus plus, hierarchical clustering. In this clustering, we'll see divisive and agglomerative clustering, and at the end we'll see dbScan, density-based spatial clustering of applications with noise. So now these are the few examples of the clustering algorithms or the unsupervised approach. Next in the list is deep learning. Now this deep learning is a subfield of machine learning that uses the artificial neural networks to learn from the data. Now these networks consist of layers of interconnected neurons or the nodes that process the information like biological neurons. So if you want to master deep learning, you need to understand this ANN, artificial neural network. Now these artificial neural networks are the base or the foundation for this deep learning. So I have included these topics to understand this ANN. So starting from how neural network works, how it is built, we'll see input layer, dense layer, and the output layer, how forward propagation works, how backward propagation works, and what is the role of these activation functions, optimizers, loss functions, and weights and bias in case of forward and backward propagation. And these play a very crucial role in ANN. Now, this is a small example of how neural network is built in case of ANN. So next we'll understand about the CNN, convolution neural network. So guys, if you want to perform any kind of image analytics, video analytics, or if you are working on any face recognition kind of use cases, you can use this convolution neural networks. So you'll understand about convolution operation, kernels or filters, padding, pooling, data augmentation, and dropout layer. So this is the example of the CNN or the convolution neural network. We'll understand about the input features like image or the video. Then we'll understand about convolution layer. We'll see what is the number of filters, and at the end we'll see how pooling and padding is applied on top of this. So next we'll understand about RNN, recurrent neural network. So there are few architectures in RNN which are typically the base for this generative AI and the LLMs. So here we'll understand about few RNN applications, LSTM, long short-term memory, which is very much important architecture in RNN, bidirectional LSTM, GRU, gated recurrent unit, encoders and decoders, and after this we have transformers also. The transformers is the base for this generative AI and the LLMs. Now here is an example of this recurrent neural network, so the RNN, and this is the LSTM, which is basically the long short-term memory, which is very much important architecture in RNN. So next in the list is computer vision. Now this computer vision enables the machines to interpret and understand the visual world, opening up a myriad of possibilities. From autonomous vehicles to medical imaging, the CV algorithms empower us to analyze and interpret the images and videos, revolutionizing the industries and enhancing the human experiences. So I have included a few topics to understand this computer vision, starting from convolutions and then learnable kernels filters, and we'll understand few architectures starting from the LeNet to the object detection. So here is an example of computer vision. We'll understand how image is taken, what is the feature extraction stage, what is the deep learning stage, and we'll understand how those architectures are used here in computer vision. So next in the list is natural language processing or NLP. Now this NLP bridges the gap between human language and machines, allowing us to analyze, understand, and generate text at scale. From chatbots to language translations, NLP algorithms allows us to extract valuable insights or valuable information from the textual data and communicate with machines in a more natural way. So I've included a few of the topics to understand this NLP or the natural language processing. First off, we'll understand why this NLP is required at first place, and then we'll understand a few of the techniques like tokenization, stop word removal, stemming and lemmatization, bag of words, TF-ID of word-to-word embeddings. Then we'll understand about POS tagging and the NER. Libraries used in NLP like Spacey, GenSim, NLTK, Stanford NLP and all. Next, we'll understand about natural language understanding like NLU and natural language generation, NLG. Then we'll go ahead and see advanced NLP, like where we'll see transformers and the BERT, bidirectional encoder representation transformer, and then ELMO, ELBERT, GPT-1, GPT-2, GPT-3, GPT-4 series. So you guys might have used this ChatGPT, right? And the base for this ChatGPT is nothing but this GPT series. And this GPT is nothing but generative pre-trained transformer. Now these are the few of the applications or the use cases of this natural language processing, and we will implement few of the use cases in our NLP series or the natural language processing series. Next in the list is generative AI. Now this generative AI pushes the boundaries of creativity, empowering us to generate new content ranging from images, music, and even text. Through techniques like generative adversarial networks or the GANs and transformers, we can unleash the power of AI to create never seen before content, sparking innovation and fueling creativity. So here are the few of the topics which are covered in case of generative AI or the LLMs. First off, we will understand about history of generative AI and the LLMs. We'll understand about transformers and attention is all you need paper. This is very much important paper. Attention is all you need. We'll understand this into the deeper. So now we will go deep dive into LLM architectures. Now key components of building blocks of LLMs, different LLM models, and then how LLMs are trained, the large language models are trained or the build, and then generative AI frameworks. This is very much important. Vector database used, then different use cases of generative AI, and then evaluate, how do you evaluate your large language models, and then fine tuning the large language models. Now this fine tuning of LLMs is very much important because LLMs or the large language models are built on a very huge amount of corpus data, and then humongous amount of computation power is required for building these LLMs. Now, this fine tuning typically helps us to build our models with very less amount of data and less amount of computation resources. So we'll understand few of the fine tuning techniques like the SFT, supervised fine tuning. RLHF is reinforcement learning with human feedback. PEFT is parameter efficient fine tuning. LoRa is basically low rank adaptation, and the QLoRa is quantized low rank adaptation. And at the end, we'll understand few of the challenges, and then we'll understand about prompt engineering and RAG, retrieval augmented generation. Next in the list is big data. Now, this big data has transformed the way we collect, store, and analyze the data. With the explosion of the digital information, traditional methods struggle to handle the sheer volume, velocity, and variety of the data. Through the technologies like Hadoop and Spark, we can process massive data sets efficiently and extract valuable information or valuable insights from the data that were previously hidden. So here are the few of the topics which I've included for big data, starting from HDFS, Hadoop distributed file system. We'll understand this, and then we'll understand the Hadoop architecture and the Yarn architecture, and then Hive, Scoop, Kafka, and then Spark. So Spark plays a very important role in data processing. We'll understand about Spark architecture, RDDs, lazy initialization, action and transformations, shuffling, very much important, wide and narrow transformations, Spark SQL, streaming, and then other features of Spark. And here we'll understand about the Spark architecture. So guys, apart from this, I'm planning to make a videos on this resume building where we'll see about data science, machine learning engineer, NLP engineer, GenAI specialist, and big data. So I'll create separate videos specifically on the career talks, and then this will include AI, data science, machine learning, deep learning, NLP, GenAI, and big data. I'm also planning for the mock interviews. So if anyone of you are interested, please send me your CV or the resume in the comment section. I'll plan and set up the mock interviews for you guys. So the conclusion is, as you embark on your data science journey, it's not just about mastering tools and techniques. It's all about cultivating curious mindset, embracing challenges, and continuous learning and growing. Thanks for watching. Hit the like button if you really like this video. Please subscribe the channel for more such videos and share with all your friends. I'll see you all in the next video. Till then, take care, keep learning, and keep rocking.